Welcome to the part 2 of special problems based on remainder theorem. We have already solved two problems which are special in the last lecture, and in this lecture also we are going to solve two special problems. Let's read the problem number 1. On dividing a number, let's say the number is a, by 6 and 7, we always get 4 as the remainder. Find the highest possible 3-digit such number. So this is the problem number 1, and in this problem there is a number a and we are dividing a by 6 and 7. So a is divided by 6 and a is divided by 7, and always we are getting 4 as the remainder. So remainder in the first case is 4 and remainder in the second case is also 4. Now there is one direct formula to calculate the answer, and if you are interested about the derivation of the formula, then you can do it by yourself. The derivation part is not important, that's why I am not discussing it here. The formula is very simple. You can easily remember the formula and you can apply it whenever you have this kind of problems. So let's try to understand how and when to use the formula. I will generalize the condition. On dividing a number a, on dividing a number, let's say the number is represented by uppercase a, by lowercase a, lowercase b and lowercase c. These are the three numbers by which we are dividing this number, and if we always get k as the remainder, then the number which is uppercase a will be. So this is the general condition, and whenever this condition is there, you can directly calculate the number a by using this formula: small n multiplied by the LCM of a, b, c plus k. So this is the formula, and I will put this formula inside the box. N is an integer. This n here is an integer. A, B, C are the numbers by which we are performing the division, and you need to calculate the LCM of these three numbers, and then the result will be multiplied by this integer. You can select any integer of your choice, but here we have this condition, highest possible 3-digit number, so we will choose n according to this condition and then add the constant k, which is actually the remainder we are getting. It is same in all the cases. Like here 4 is the remainder, so simply this 4 here is the k, 6 is a, 7 is b. So we have everything to use this formula. The number a is simply equal to n multiplied by LCM. In this case we only have two numbers, 6 and 7. So a and b are there, c is not there. So we will find out LCM of 6 and 7, and then we will add 4 to the product of n and LCM of 6 and 7. LCM of 6 and 7 is equal to 42. So n multiplied by 42 plus 4. Now if you choose n as 1, then you will get the number a as 42 plus 4, which is 46. The obtained number is 2-digit number, but in the question we need to find the highest possible 3-digit number. So if you choose n as 3, you will get a as 130. This is 3-digit number, but this is not the highest. So the condition of 3-digit is satisfied, but it is not the highest, so the overall condition is not satisfied. So to obtain the highest possible 3-digit number, n should be 23, and when n is equal to 23, the number a is equal to 970. So this is the final answer. I hope you understand how to solve the problem number 1. Now we will solve the problem number 2. In the second problem, it says find a number, let's say the number is a, which after adding 5 is divisible by 6 and 7. So what we are doing here, we are adding 5 to a And after this, if you divide a plus 5 by 6, it is divisible. This means the remainder should be 0. In the same way, if you add 5 to a and divide it by 7, then also it is completely divisible, so the remainder is equal to 0. And we need to find this number a. Again, there is one direct formula. No need to worry about the derivation. You can simply remember the condition and use the formula. So I will first write down the condition and then the formula. The condition says if a number, let's say a, after adding k is exactly divisible by a, b and c, then the number a will be, the formula is a is equal to n multiplied by LCM of a, b and c, a, b and c minus k. So this is the formula. I will put this formula inside the box. I hope you understand the condition and also the formula. There's difference between this formula and this formula. Here k is the final remainder and also it is added with the LCM of ABC multiplied by n. Here k is the number which we are adding in the number a to make it completely divisible by a, b and c, and k is subtracted from n multiplied by LCM of a, b and c. So let's try to find out the answer in this case. On comparison, you will find 6 is equal to a, 7 is equal to b and 5 is equal to k. Now we will use the formula and the number a will be n times LCM of 6 and 7 minus k. K is equal to 5, so I will write 5 in place of k. LCM of 6 and 7 is equal to 42 and I will consider n as 1. So 1 multiplied by 42 minus 5 will give us a equal to 37. So this is the answer of the second problem. Now we will move to the homework problems. There are 2 homework problems in this lecture. The first homework problem depends on the first question we have seen, so you have to use this formula, and the second homework problem depends on the second question we have seen, so you have to use this formula. I will quickly write down the 2 questions on the board. So these are the 2 questions. Once you have your answers, post it in comment section. There is one point regarding the question number 2. Here n is equal to 1. If you take n equal to 2, you will have different value of number a, and that answer is also correct. So you have to choose the value of n depending on the options given in front of you. So this is all for this lecture. If you have any doubt, you may ask in the comment section, and don't forget to solve the homework problems.